Hi folks, I had intended to write a blog on prototyping today, but I decided at the last minute to make it a video and kind of incorporate it in my Automation Academy stuff, even though this is probably going to end up on my Automation Primer site and on YouTube, which is where I usually put a lot of these videos. But rather than just writing a bunch of stuff about prototyping, I figured I would make a video about it and probably still do a little write-up on the Automation Primer. Hope you enjoy it. Thanks. What prompted this blog post or video is that last week I was actually contacted by a potential new customer about prototyping. And I can't talk in particular about who the customer is or what the prototypes were, but it kind of prompted me to think about the prototypes that I've built in the past. The first one I ever did was this Kiesler automotive transmission tester. And this was in about 2001, which was 20 years ago. And the original intent for this was to simply leak test it. And that's what you see here is a little panel that closes up all the orifices on a transmission and pumps it full of air and then does what's called a decay test. And we see how long it takes the air to leak out of it. And that simulates how long it would take transmission fluid to leak out of it, right? So we want to make sure that all these transmissions are done properly. There were two of these built. This was the first one. And we had intended to even possibly build an add-on module off here to the right side that would spin it up. It would mate up to the transmission and spin it up and do leak tests and RPM tests while the transmission was spinning. That never got built. The company actually went out of business before that. The guy, Mr. Kiesler, is now, I think he lives in Missouri, but at that time he lived in Knoxville, and he built custom transmissions. It was kind of a neat project, but I think he's moved on to some other things. So the second prototype that I ever built was actually a kind of a commercial project, and this was prompted by TRW Koyo, who had these poka-yoke machines, and the poka-yoke machines were custom built and they were all different, and they had 17 of them in this plant. So the story behind this is they called me up about rebuilding some of their poka-yoke machines, and I went into the plant. They were about 45 minutes away from me, and I said, okay, how do you want to do this? And they said, well, we actually are in production on these, but we're about to change the model year, so we need to rebuild all these to handle new products, and could you come in and actually work on them here? And I said, well, the problem is I'm 45 minutes away from you, so I'd have to drive in here, retool things, and then go back home and then drive back in here again, and I'd have to charge you for all that time. And I thought about it for a while, and I said, well, what if I built one machine that could replace all 17 of these? And that's what you see here. So this is a poka-yoke machine with a removable base on it. You can see here that there's some tooling, but the electronic part of it, which was what I was best at, is the controls part, would actually attach to sensors on all the different bins and things, and it was what's called a pick-to-light system, which is a pretty standard piece of equipment. And this was where I really first started thinking in terms of building a whole bunch of these. And so I built a control system that was very generic. It had a touch screen where you could basically select a sequence of operations, and I realized after that, after this one was built, that this was a really good sequential control engine to do anything, not only pick-to-light systems and not only part assembly verification. Once again, I tried to turn this into a commercial project. I brought it to several trade shows, and I didn't get a lot of interest, and I realized also, I put quite a bit of time and money into this, but I realized after I was done, well, building it is one thing, but selling it is an entirely different thing. So the trade shows, I actually picked up some extra business from it. They saw that we could build machines and said, well, we don't really want one of these, but can you build us some other stuff? So I got other jobs out of it. It wasn't necessarily a bad thing. One of the other jobs I got out of it was this Howmet core press. And I did a lot of business with Howmet. They're a division of Alcoa. And they saw that we could build, machines out of aluminum extrusion and things like that. So I had a really good relationship with an engineer there, and we did a whole lot of systems. But this one was one that we built made sure that it worked correctly, and then propagated it 22 times. So we built 22 more of these machines. And of course, the first one went through a lot of different iterations. One of the things I learned, probably the most important thing I learned in prototyping these machines, is document everything very well, because you're going to have to rebuild it, right? You're going to have to document it controls wise, write your programs very well and document your programs. Also document every step, every little part you buy, and you'd be surprised all the little individual screws and things that go into these. So most of the time when you build a prototype like this, you're trying to keep the cost of the final product as low as possible. And that's where I really kind of started developing some of my engineering notebook documentation and teaching other people how to document projects very well. So a lot of people know me now for training, but as you can see here, I ran a company that was mostly controls and became a machine building company in the early 2000s, and that's where a lot of these came from. I left or I closed this company in 2006 and went to work for a big machine builder. The big machine builder built a lot of custom machinery. This was Wright Industries in Nashville, here close to me. I moved from Knoxville. And we used to build a lot of machines called proof of principle machines. And the idea there was we would build a machine to show the customer that the concept behind the machine would work, and the customer would fund this. This is a little bit different from a prototype. Now I'm going to throw out a definition for prototyping that I've kind of just written up here. I'd say it's an initial project that's intended to be done multiple times, possibly to be turned into a commercial product. With a proof of principle machine, or a POP, the definition would be slightly different. One, of course, you're trying to keep the cost low, but you're really just trying to prove that it works more than anything else. In both cases, you need to prove that it works, but in some cases, you may bring a bunch of users into it, right, and have them do some user testing of the software and the interface. And all this would be done on the first or second machine, and then you would intend to multiply it many times for a commercial product. So this is a little bit different than a proof of principle, where you would build one and then you may only build one final project, one big machine that does everything that you want it to do, and you would polish it up. When you build a POP or an initial project, you still want it to look pretty good, but you're not as concerned about the commercial, the appearance aspects of it and things like that. You are more concerned with its functionality, but you still want it to look good. You still want to wire it well and document your program really well, because remember, you're going to reproduce it, and you also don't want the customer to think that you don't know what you're doing. Now, my latest prototyping adventure involved these trainers, which I built out of plastic initially and documented everything very, very well. And the intent for these was to interface with these Fisher Technique toy factories. These are pretty cool. I even went to Europe and talked to Fisher Technique about this, and have formed a relationship with Studica, who is the master importer of all these Fisher Technique models. And I built a pretty elaborate system of trainers and interfaces with these Fisher Technique factories. This is a kind of a picture of what the whole factory can look like, and this really simulates a large factory. It has sensors and things like that. But one of the really important details of this was to document everything as I went along, and I created this book. And this book is actually published. It has a formal ISBN number, and I kind of spent the extra $80 or so putting this online, available for people, and surprisingly, people have bought it. And what it has in it is a lot of explanations of how to make things, how to wire things. You can see both this enclosure kit where I put all the parts in here. I listed all the parts, and this went through a lot of kind of iterations. You notice here, for instance, that this list does not include where I got all these parts from. But I do have a master list where I can tell people. I originally had intended to market these and sell them, mass produce them, that kind of thing. But it really has turned out, especially for a one-person company, not to be feasible. But the book is still valid. And as you can see here behind me, I have one of the old enclosure kits. I have one of the newer enclosure kits, and I'm popping up a little picture here on the screen of the new enclosures that went through an iteration with 80-20 corners, and they were quite a bit more rugged. I'm going to go ahead and pause this video here. And here, what I want to show you is the parts list that I had created for this trainer setup. And you can see here I have the initial cost for everything, and then I have a lot of different lists here for different components for different things. So I have a troubleshooting kit, I have the enclosure kit that you saw there with the corners, I have the PLC kit, which is just the electronic parts. I even have breakouts for all of the wiring. You can see here individual wires, and all of that went into this book. So you can see here cost of different PLCs. These were all planned, cost of Fisher accessories, and then I did math to figure out, okay, what would the markup be on all these different things for the commercial product. And you can see here that there are a whole lot of little individual screws, and I went to places like Home Depot, and a lot of the local vendors ordered some things from Automation Direct. There were a lot of special purpose things, a lot of extrusion from Bertelkamp. And what I realized after getting this together is that it really wasn't commercially feasible, especially to build one and two of these things at a time. So that's often what happens with prototypes. You'll put together a system like this, and you'll find out that, you know, the only way to really make this feasible is either to have it made in another country, and even then maybe make 10 or more at a time. The problem is if you want to sell one or two at a time, you would have to have 10 in stock. I actually had a deal worked out with a local guy. Well, he's not so local. He's in Massachusetts. He's a kind of a well-known guy, and he wanted to sell these. But we came down to the problem that I couldn't put together a kit economically and send it to him one or two at a time. There were going to have to be some kind of a minimum order of 10 or ideally 100. And then the problem is I'm a one-person company, so I can't provide 100 at a time as an individual. So it was either grow the company or kind of shelve the project. So in my old training facility, these were some of the areas that I had for prototyping. This was a electronic area where you could wire things up, and you could do things with Raspberry Pi or Arduino. And I had bought quite a few components, bought out a lot of the local Radio Shacks for doing the wiring and things. Here you can see a fabrication area, and had a drill press and a chop saw and some other things that you could make little parts, usually out of plastic or extrusion. You could cut extrusion and that sort of thing. And I have a small mill at home that I could use to make some pretty detailed parts, and I used a lot of those internal parts here to build this mini factory. And this was not really a prototype, it was just a kind of a training system that I had here. But I was planning on doing some kind of prototyping until the big tornado hit. And of course the tornado took out my facility. And so I'm now in a new facility, which is actually a small house. And you can see here, this is my small mechanical fabrication room. It is just one of the bedrooms in the house. And then this is my electronics room where I do the Arduino and Raspberry Pi stuff. And I did manage to rescue some of my components and things, but obviously I don't have my big mini factory, and I don't have things like a chop saw. I do still have my small mill at home and that sort of thing. But everything is going well here, still able to do small prototypes, and of course, train other people and help them to do their prototypes. So if anybody needs those kind of services, I am happy to help you. I hope you enjoyed this presentation and learned a little bit about prototyping. If you have any questions or comments, you can email me here at flamb, F-L-A-M-B, @automationllc.com, and I'll try to answer any other questions you have. And of course, as usual, please join the Automation Academy. Thank you.